Welcome to True Projects. In this video, we are going to explain about a project titled An Open-Ended Continual Learning for Food Recognition using Class Incremental Extreme Learning Mission. The project's introduction delves into the concept of open-ended continual learning, which involves the continuous influx of new images belonging to the existing class and the emergence of new classes. Within this context, the project specifically focuses on two types of incremental learning: data incremental learning and class incremental learning. Data incremental learning aims to enhance recognition performance for existing classes and adapt to domain changes by leveraging the newly available images. On the other hand, class incremental learning continuously acquires knowledge pertaining to novel classes. And this framework incorporates the various techniques, including the transfer learning applied to deep model for feature extraction, relief for feature selection, and a unique adaptive reduced class incremental kernel extreme learning mission for classification. By combining these approaches, the project aimed to enable the efficient and accurate food recognition and continually evolving the environment accommodated both the addition of new images from the existing classes and the novel classes. The project aimed to introduce an innovative open-ended continual learning framework for food recognition that encompasses both data incremental learning and class incremental learning. The proposed framework employs transfer learning on the deep model to extract the features. The main goal is to overcome the challenge associated with catastrophic interference problem during the class incremental learning and minimize the need for the training the model, which typically requires the computational resources and time. To evaluate the effectiveness of the proposed framework, it is assessed against four widely recognized food benchmarks and a recently collected food data set. The evolution of demonstrate the framework's ability to incrementally learn new classes while mitigating the catastrophic interference. Furthermore, the framework shows its capability to adopt the domain changes while maintaining the competitive classification performance. By addressing these challenges, the project contributes to advancement of food recognition system with improved efficiency and adaptability. These are the requirements that are needed to build this project. Hardware requirements are operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDEL with version of 3.7. These are the modules that are developed to build this project. The first module is upload the food image dataset. This module involves uploading the dataset of food images, which is an essential step in the implementation process. And the second module is feature extraction. In this module, we extract the features from the food images using the image augmentation technique for normalization. And the third module is feature selection. This module focuses on selecting the high-intensity pixel from the images which are crucial for training. And here, the dataset is divided into the training and testing part 2, where 80% of dataset is used for training and 20% of dataset used for testing. And the fourth module is Run Incremental ARCIKELM algorithm. This module executes this algorithm which enables the continual learning without returning from the scratch. And the fifth module is Run Existing Batch ELM algorithm. This module runs the existing batch ELM algorithm which trains the model using the entire dataset at once. And the sixth module is Accuracy Comparison Graph. This module generates a graph that compares the accuracy achieved by the both algorithms that were used in this project. And the seventh module and final module is of food recognition from test image. This module enables the food recognition by utilizing the trained model to classify and identify the food items in the test images. The execution of the project. To execute the project, first we need to open the code folder. This is the Code folder consisting of different files. The first one contains of compiled Python file and the dataset part 1 and dataset part 2 are the datasets we used in this whole project, consisting of various folders and then consisting of various images within it. And the model folder consisting of NPY files which contain the algorithm information. These files can be loaded into the project code during the runtime to utilize the trained model for various tasks, such as making predictions on new data or performing the specific operations. And the test images folder consisting of various images which are used for testing the model performance. And the category file is a text file, and the increment, main and training are the Python code files, and the run is a bat file. Instead of executing the program in command line interface, we used this Windows bat file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. First, we need to click on Upload Food Images Dataset button and select the dataset and click on Select Folder button. Here, we get a screen of Food Images Dataset is loaded and click on Feature Extraction button. By this, the features are extracted from the image dataset and the total images found in the dataset is of 3428. The total images found in the second dataset incremental training is of 362. And click on Feature Selection button. By this, the features are selected and we get an sample image whether the dataset is correctly loaded or not. For this, we are redirecting this image on the screen and close this image. And here we found the total images found is 3428 and of 362. And click on Run Incremental ARCIKLM algorithm. By this, the model is generated on the pre-processed, feature extracted and selected data set with an accuracy, precision, recall and F-score of 100%. And then click on Run Existing Batch ALM algorithm. By this, the ALM model is generated with an accuracy of 30%, F-score of 22%, recall of 33% and precision of 21%. And click on Accuracy Comparison Graph button. By this, we get an graph where x-axis represents the algorithms we used and the y-axis represents the count of each algorithm and the value assigned to it, where each bar represents the one metric we used and the blue bar represents accuracy, orange bar represents of F1 score, green bar represents of precision and red bar represents of recall. And close this graph. Click on Food Recognition from the test image button. By this, it redirected to the test images. We need to select any one of the image from this folder and I am selecting this image and click on Open button. Here, the food is recognized as of pizza. And this way, we can recognize the food by using the Extreme Learning Mission algorithms. In conclusion, the project proposed a new open-ended continual learning framework for food recognition that can handle data incremental learning and class incremental learning. The proposed framework uses the transfer learning on the deep model for feature extraction, feature selection, and a novel adaptive reduced class incremental kernel extreme learning mission for classification. The proposed framework is evaluated against 4 standard food benchmarks and a recently collected food data set to demonstrate its effectiveness in learning the new classes incrementally with less catastrophic inference and adapting to the domain changes while having the competitive classification performance. The experimental results show that the proposed framework outperforms the existing method in terms of classification accuracy and reduces the need for model retraining, which demands high-end computational resources and significant time. The proposed framework can be used in real-time applications of food recognition where the dataset is open-ended and dynamic involving a continuous increase in food samples and food classes.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.